Good morning friends, I am Ashwini Magade. I am from Electronics and Telecommunication Department. Today I am going to discuss about induction heating. Now let's see what is induction heating. Induction heating is a contactless heating method of bodies which absorb energy from the alternating magnetic field generated by induction coil, or it is also defined as heating of material by means of an electric current that is caused to flow through the material or its container by electromagnetic induction. Principles of induction heating. Chain of phenomena. Now let's see. It is the power supply circuitry. The power supply delivers current I1 to the induction coil. The coil currents generates magnetic field. Line of fields are always closed and each line goes around the current source, that is coil turns and workpiece. The middle part which is going to heat is known as a workpiece and the coil turns are known as work coils. The alternating magnetic field flowing through the part cross section induces voltage in the part. Then induced voltage creates eddy currents. The induced voltage from the supply generates eddy currents. The eddy current I2 is given here. The induced voltage creates eddy current in the part flowing in the direction opposite to the coil current where possible. Now eddy current generates heat in the part. Now specific features of induction heating. In induction heating, heating is contactless. There is no direct contact with the object of material to be heated. The heat generated occurs inside the part. Heat generated does not go outside, or heat dissipation is not takes place in the induction heating method. The method can provide very high power densities. Heating may be highly selective in the depth and along the surface. Any processing atmosphere is suitable for the induction heating. Very high temperature may be created. Standby losses of equipment are very low. A very fast startup. Heating may be easily programmed and automated. No pollution of surrounding takes place compared to the safe gas heating. Now, design. In that design, here one job is given. One heating structure is given, electromagnetic digital display is given. In the diagram given here, it is the job, heating plate, up and down movement, angular movement, digital display, internal heating system, base and moving vehicles. These some parts are explained. The job is set in the heating plate for the heating purpose of the job. The angular movement gives the circular movement of this heating plate, and up and down movement gives the up and down movements of the heating plate. In digital display, it is going to display the heating or temperature of the circuit. The internal heating system gives, as we discussed before, it produces eddy currents and it induced heating. Then base is firm and holding all the circuitry along with it. Moving wheels are for the movement of the vehicles. Now, parts of an induction heating system. An induction heating system comprises a tank circuit, a power supply and a work coil. In industrial application, there is a sufficient current passing via the coil to need water cooling. Therefore, a basic installation contains a water cooling unit. The alternating current from the AC line is converted through the power supply to the alternating current that is in the line with the combination of coil inductance, work head capacitance and the component resistivity. In the circuit given here, power supply and tank circuit are connected. Then power supply is connected to water cooling system and also it is connected to temperature controller and infrared pyrometer. Here workpiece is fixed up On the fixer, here the induction coil is mounted with the tank circuit. Tank circuit is a workhead, power supply is inverter. It is a typical induction heating system. From power supply gives supply to water cooling system. Then for tank circuit, and power supply gives AC current to this coil, and coil generates ED currents to form extra temperature to heat the workpiece. Now, there are two mechanisms of energy absorption: ED current mechanism and hysteresis mechanism. ED currents are heating currents heating occurs in all conductive materials, magnetic or non-magnetic sheets, steels, coppers, aluminium, graphite, molten glass or oxide etc. When they are placed in the alternating magnetic field, eddy currents always flow in the closed loop, and for effective heating, there must be a good path for control to flow in the part of the heated. For example, this is easy to heat a wire loop, but almost impossible to heat a thin wire. Then the loop is open. It is in this eddy current always flow in the closed loop, and effective heating takes place in eddy current as compared to the hysteresis heating. And it is easy to heat more number of elements than a thin wire or a single element. Now, hysteresis heating is zero in non-magnetic material, that is aluminium, copper, hot steel, or responsible for small percentage of heat generated in contact magnetic bodies, mainly steel at low or middle temperature. However, in the magnetic material composed of particulates, including magnetic flux concentrators, hysteresis may be the major source of the heat generation. Each particle is heated individually, and the workpiece may have any shape and size, that massive bodies, strips, films and wires. Hysteresis works on any type of shape of material, but the eddy current cannot work on the thin elements like thin sheets or thin wires. And hysteresis can work on any type of material, including massive bodies, strips, films and wires. Now, operating frequency. A 20 mm, example 1, a 20 mm steel bar can be stress revealed by heating it into 540 degrees Celsius, that is 1000 degrees Fahrenheit, using a 3 kHz induction system. However, a 10 kHz system will be needed to harden the same bar by heating it by 870 degrees Celsius, that is 1600 degrees Fahrenheit. Hence, it can be said that higher operating frequencies, mostly more than 50 kHz, can be used to heat smaller parts with induction, and lower operating frequencies can be used to heat larger parts more efficiently. In the case of advanced solid-state induction power supply with an embedded microprocessor control system, consistent and effective heating techniques are achievable based on the fact that all parts are placed at the consistent location within the coil. Now, advantages of induction heating. Short heating cycles and high production rates. Induction heating can be obtained by giving less amount of supply and less amount of heating cycles required for more generation of heat, and it is high production rates are there for the induction heating. The better metallurgical results due to the fast and clean heating. Then energy saving due to selective and high efficiency. Good control and repeatability is present in induction heating. Minimal or no surface oxidation and decarbonization. That is, there is no oxidation takes place in induction heating. Just because it is a closed loop system, there is no oxidation takes place, and it is fast process, so it don't give time to object to be oxidized. Then lower distortions, favorable for industrial environment. Inline heating, no pollution, push button performance. Some processes may not be accomplished other than any induction, safer surrounding environment. The major applications of induction heat: melting, forging and forming, heat treatment, welding, brazing and soldering, shrink and fitting, bonding, in inductively coupled plasma and crystal growth are some of the applications of the induction heating. Thank you.